Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Jesus. And you can reach us here at Bakersfield with the number 636-4357. Or if you're an SLO, you can call toll free at 1-866-636-6284. You can also reach us by email at dothemath@kern.org or watch us online at dothemath.net. And look for us on social media, Facebook, Instagram, Twitter, and YouTube.
All right, a lot of ways to get a hold of us here at Do the Math. And we do have a very special guest in studio. We'll meet that young lady in a little bit. Since you're in studio with us today,
Yes.
How is CSUB going? What's
It's
going on at the university?
Yeah, we just
Anything
started.
new, or?
We just started our second semester, and a strong start, and doing well. We have a lot of students going through there. No parking spaces at all.
I can imagine they're in the middle of the day. So explain to everybody once again your role with the university.
Sure. I'm in teacher education over at Cal State University Bakersfield. I run a couple of residency programs, actually. I'm with a rural residency, and now we're starting with Kern High School, so I'm excited about that. Next year, I'll be over there full time.
Well, good. And the Kern County Math Council.
Right.
I see
I
you're
represent there as
representing
well.
the shirt
Yeah,
there. So
yeah.
tell us a little bit about that Math Council.
Math
also.
Council is a group of math educators really throughout our county, and what we do is we just reach out for support, and we attend conferences and try to bring all these resources back to our teachers here in Kern County. We realize their workload, so we just try to help them out.
Yeah, because I know there are a lot of events. You guys have a couple of events during the year.
We do.
Have social gatherings
We do
just
as
for
well.
everybody to get together, and then some workshops and things like that.
Most definitely professionally related, but we do offer some social opportunities as well, just some networking and kind of,
Now, if somebody wanted to find out a little bit more about that, do you know the website offhand or a phone number or
Yeah,
how that somebody
Kern-
can learn more?
Yeah, kerncmc.org.
So kerncmc.org.
Yeah, essentially, yeah.
All right, well, you know what? We do have phone tutors available until 5:30 this afternoon. And before we get to anything else, let's first take a look at today's Math in the News. All right, now I'm going to assume that you are not as old as I am, okay? Do you remember when email became popular and you started finally sending more email than regular mail?
I remember the term snail mail.
Snail mail, okay.
Right?
So,
And
all right.
so I was there right at the beginning of it. I would imagine it was late 90s, maybe
Okay,
mid-90s.
so did you do a lot of snail mail where you sent things to people?
Not so much, no.
Okay.
Very frustrating to me.
All right, so you kind of grew up mostly then with using email.
Electronic, yeah.
All right, and inflation happens with everything.
Oh, yeah.
Right? Prices go up, prices go up. Well, one of the things with regular mail, snail mail, and there are kids that have no idea even what we're talking about right now. But it is important to know how to address an envelope, things like that. So hopefully they're still doing that in school. But anyway, one of the fun things about that was being able to collect stamps and seeing all the different stamps that were out there. And we have just put an assortment here. So a lot of people will recognize some of these personalities, let's say. Did you like Elvis, the music?
I did, yeah.
The King? Yeah.
The King.
I remember we were driving on the New York Thruway when Elvis Presley, when it was announced that he died. And I was probably 14, 15 years old at the time. And I remember my mother, because all three of us kids were sitting in the back, and I don't remember at that time if there were even seatbelts required. But it was just like, hey, whoa, 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 they're talking.
Yeah,
I mean, that was a big event.
Yeah.
And we were just talking about this movie right here, one of our favorites.
It is.
Right? With the Oompa Loompas and a lovely little crew they are, the Oompa Loompas and their songs and riddles and things like that. Do you remember this movie?
I just saw this one right now, and I recognize it instantly. Yeah, I saw it look on the monitor there.
All right. You know, I mean, there are different stamps for people that collect specific types of stamps.
Sure.
Audubon Society people, there's just countless
Oh yeah.
collections of stamps. Christmas from 50 years ago.
4 cents. There you go.
Yeah, 4 cents. I don't remember 4 cents.
Right.
I was there, but I don't remember 4 cents. But the reason I bring this up is because I believe it was yesterday, stamps, the forever stamp, increased 10%. So here it goes. Takes effect on Sunday. So this Monday just happened. The first class forever stamps will increase from 50 cents to 55 cents. So that increase, people go, well, it's 5 cents. Well, it's 10% because 10% of 50 would be the 5 cents. So it had a 10% increase. Because some people will look at that, students will go, well, it went from 50 to 55 cents. It increased 5%. Well, it increased 5 cents, but that was 10%.
Oh yeah.
So we can see that. And we can see some of the other prices here. So small boxes, the other boxes and things like that. And I figured, all right, well, we can see a little bit about that, but how do you figure out a percent change? So if it's going from one price to another. So now we can see that a percent change is where you set up a ratio that compares quantity to the original amount, all right? So we can see that the amount of change that we had from 50 to 55 was 5, divided by the original amount, which was 50, so that we can see that the final amount, you're going to divide it all out, and then you multiply it by 100, you're going to get to 10%. And that is today's Math in the News and the increase in stamps. So in studio with us right now, we have Jalpeen. How are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Whitley Elementary and I'm in 6th grade.
And how is Whitley? Because that's is it the first year that school's open?
Yes.
This is the first year?
Yes.
Okay, so obviously it's your first year there, and you're in 6th grade, so it's your first and last year there.
Yes.
What are some of the things that you like about Whitley compared to wherever you were at school before?
Everything's new, so all the classrooms and all the books of the library is really new.
So you like everything being brand new, right? So the library, you're getting books, you're the first person to check it out probably, right?
Yes.
Instead of having them, I remember, you know, these things been around here for 40 years, yeah. Stains on these things, pages missing,
pages,
curled,
yeah.
things like that. Anyway, so before we go on, what I'd like you to do is if you had to use, don't worry about what the stamps are worth. Okay, so like this is worth, it was worth 1 cent, right? This is $4.29.44. If you had to mail a letter, which one of these stamps would you put on your envelope?
I would take the one with the 20.
So you would take this one right here?
Yes.
Are you familiar with what this is? That,
It looks like extraterrestrial.
right, that movie, right? E.T., right? So that's the one you would select. All right, I was just curious to see
Very
which
cool.
one you would select on that right there. Now, I'm sure, now you use email, correct?
Yes.
Do you know what we are talking about when we talk about snail mail or regular mail?
No.
Okay, there we go. So how old are you? Probably 11?
Yes.
Okay, so your family has a mailbox, I'm sure.
Yes.
Okay, so when you go into the mailbox and you get mail out, that's snail mail, all right? Because the post office delivers these things, right? What they do
Yeah.
is they bring a lot of junk mail, right? But they also bring the bills, which I'm sure your parents are happy to see all the bills that come in there. But anyway, that's the difference between snail mail because it takes a couple of days to get it, which is why they call it snail mail as opposed to email, right? Because if you sent me an email, how fast would it take and I'd get it?
About 1 millisecond.
Right, I mean, as soon as you hit it, right, I'm going to receive it, right? So it happens that quick, all right? So maybe someday you can, you know what, go to your teacher and say, hey, can we address an envelope? And make sure you guys can do that, all right? See what he says. You ready to do a little math?
Yes.
All right, we're going to do a quick one because we've got to head out to the schools in a moment. But head on over to the board, and I'll give you a problem, and you've got Jesus to help work it out for you in case you're stuck. All
I'll
right?
write it and then we'll
So
let you.
start over all the way on the left because this is going to be a lengthy problem, all right? 3 squared minus 2 times 3 plus u, so that will be our variable,
Okay.
equals, and then open a set of parentheses. 3 to the third power, or 3 cubed, minus 3 times 8,
Minus 3 times 8.
close parentheses, open parentheses, 2, close parentheses, plus u. Now, Jalpeen, this is not something you're doing in your regular classroom. This is some extra work you're working on, correct?
Yes.
But you're familiar with equations and kind of how to go about them, right? So explain to Jesus how we're going to solve this problem. And you can go ahead and write it up there and
I'll let
get
you
going.
take the pen first.
You always start with the order of operations.
Okay.
So you always solve the parentheses.
Parentheses first.
Yes.
Okay. And would you like to point to which one you're going to start first? Because I see 2 sets of parentheses here.
I'll do this one.
Okay.
Okay. So 3 to the third power is 27.
Okay.
Because
That-
3 times 3 is 9 times 3 is 27.
Fair.
Minus 3 times 8, and you always do multiplication first. So that's 24.
Okay.
So, and you want to subtract that by that. So that's 27 minus 24.
Okay.
And that is 3.
Perfect.
And the 2 is, you just leave it 2.
Okay.
And then you bring everything else.
Okay. So we're just going to rewrite the left side, and that's what she's doing right now. And why don't we go ahead and put a parentheses around the 2 also, just to kind of keep it the same as the last problem. So we've worked through this first parentheses. Now we have our second parentheses, a number 3. What is happening with this 3 and this parentheses 2? Do you know what we have to do? Or when you see them right here, what does those 2 parentheses side by side really mean as an operation in math? What do we have to do?
You have to multiply.
Multiply. Very nice. Okay, so we know that we're going to have to multiply 3 times 2. That's going to be our next step?
Yeah.
Okay, go for it. And then go ahead and finish up with what you would do on that side. 6 plus u, and then we're going to put our equality here in the middle. And let's go ahead and start working on this side too, right? Go ahead and tell us out loud what you would do first on this side.
So I would solve the exponent.
Okay.
And 3 times 3 is 9.
Okay, so 3 squared is the same as 3 times 3,
Yes.
which is 9, minus,
Minus 2 times 3 plus u.
okay,
So next I would multiply 2 times 3.
okay,
And bring everything else down.
perfect. And then go ahead and write the other side in as well. And at this point, what we've done is we started to simplify both sides of our equation. At this point, what I'm hoping you recognize is that this side is still equal to this side. Your left and right side are still balanced, right?
Yes.
They're still equal to each other. I'm going to go ahead and just bring this up some so we can kind of see the next steps. Go ahead. Where would you go from here? What's the next step?
You bring all the variables.
We could. Yeah, I would agree
Or
with that.
the
We can bring them
numbers.
over. How about we also simplify this piece as well, the 9 minus 6. Do you think we can shorten that or condense it some too as well? Okay, so that'll give us,
3.
okay, and go ahead and finish writing. That'll kind of help us clean through some of this clutter, right? All right, go ahead and finish up with what you were thinking you were going to do.
Bring all the numbers here.
Okay,
So I would bring the 3.
okay, and can you tell us why you would decided to bring the 3 instead of bringing the 6 over?
Because you want to get rid of the smaller x.
Right, and that'll
Or
keep our numbers
variable,
positive,
yeah.
right? Okay, so go ahead and do that.
It turns to this side, so you make it a negative number.
Okay. So what we want to do is make this 3 change into a 0. So the way that I would take 3 and bring it back to 0 is by saying subtracting 3. Would you mind also putting minus 3 on this side? So we can show that, remember, being equals means that we have to do it to both sides,
Yes.
correct? So that's how we got 3 minus 3, 0. And now you also have to show that math. So I'm going to drag our board a little bit further down. Okay, go ahead and show us the changes that are now happening. U is equal to, okay, and your final step here would be,
To get rid of the 3,
okay, and what would you do with that 3?
you divide it.
Okay, so what we have right here is a U is equal to 3 plus U, agreed? So what we have to do is maybe we can consider condensing these U's and bringing them together on one side. So the same way that you said, hey, look at this 3 over here, I want to move it to the other side. Why don't we do the opposite of plus u and bring it to the other side as well?
Okay.
So instead of saying plus u, or how do I make this u cancel out in that way, is by saying the opposite of positive u, which is negative u. Exactly. So if I put negative u on this side, go ahead and do that. And then if we put a negative u on one side, what I do to one side of an equation, I have to do to the other as well. So now what we have is this idea where a negative or positive u minus u and positive u minus u. What happens to a u and I take away that same number? Just like when I had a 3 and I took away 3, I have a u and I take away u. What's going to happen to that u, or the value that was u?
It disappears.
It's 0 now. Yeah, it just goes back to 0 on the number line. So why don't we just go ahead and write this as 3 plus 0, which is just 3. Let's go ahead and make our final changes right here. Go ahead and put on that side is 3 equals, and then we have a u minus u, which is 0, which you said earlier. So you have 0 here on this side, so go ahead and put a 0 there.
And the beautiful thing about this problem is that I know that in your life during this year, you have seen problems with no solutions, right?
Yes.
So this is another one of those that has no solution.
Very nice.
So nicely done on that, Jalpeen, because I know some students were looking going, all right, it's going to work out. I know how these work, but I don't see how this one's working. So there are ones that are no solution.
Right.
Right now, we do have an opportunity to go out to Frank West Elementary School and visit with Devin.
Hey.
Hey, thanks a lot, Mike. Back at Frank West Elementary School with a wonderful room of third graders. Let's say hi, everybody. Hi. Some people actually said hi, everybody, only because I asked them to very literally. So wonderful at following instructions right off the bat. Hey, generally here at Do the Math, we follow a pattern of we give a problem and then the kids solve it. And for 16 years, that's been the way it's been. But today, we're going to change things up because I have not brought the problems. Our third graders are going to be creating in an activity that we call co-crafting. You can see how thrilled they are for this. They're not even paid to come up with these problems, right?
Yeah.
No, they're not. So, in our first co-crafting activity, we have been showing our third graders here at Frank West a graph. Now, this graph does not have any numbers. It does not have any words. It doesn't have a legend. All it has are two lines, different colors. And so, if you take a look, this is what our third graders have been looking at. So, what I'd like to ask our group is, what did you notice about this graph? We've been looking at this, and they've been sharing with their groups for a good 3 or 4 minutes now. So I want to open it up to the floor. What do you notice happening in this graph? Let's start around here.
What I noticed about that graph is that it looks like the red line pushed the blue line, and the blue line is shorter than the red line.
So you notice that for most of this graph, the blue line, or whatever it represents, is less than whatever the red line represents, up until it gets to be a certain point. That's a very interesting observation, and I think you're going to see that catches in a little bit later. Let's go to this back table over here. What did you notice in this graph?
What I noticed is they cut off the blue.
Okay, when you say they cut off the blue, are you talking about right over here?
Mm-hmm.
Do you think that the blue just stops existing, or do you think something is happening with whatever the blue represents and the red represents?
No, red.
So you think that whatever they both represent, they have the same amount at this point? Okay, that's a really interesting connection. At this point, whatever blue and red are is equal. What did you notice?
I noticed that the blue and the red is wider than the blue one, and the blue is a littler, and like it just crashes into the both in between lines.
So what you noticed is that this line, and I think you're making the same observation, just because there's no blue on these lines doesn't mean that there's no blue there. It just means that the red and the blue have the same amount at that time. Up until here, when red grows very quickly, and then blue catches up. And then we get to this point. Yes?
And also, there are no numbers, so how is this a number?
She said, there's no numbers, so how are we supposed to know what any of this means? would you like for me to give you a little bit of information to help you out with this?
Yes.
I'm going to give you just a little nugget here. Okay, so keep your eyes peeled on the front. Are you ready?
Yes.
Let's see. All right. Now you have, did you see the numbers?
Yes.
They're up there now. I didn't give you a ton of numbers, but I just gave you some. So, what do you think this could represent? What do you think that could represent? Yes. Yeah, let's go red shirt.
I think it represents a bar graph.
Is this a bar graph? Well, bar graphs generally have bars. Do we have bars here?
No.
We see these numbers, 10, 20, 30, 40. But 10 what? 20 what? What do you think those amounts could be? Yes, sir.
Number graph?
Well, it is a number graph. We're not talking about what the whole thing is. What could these numbers be counting? Yes.
The height for it. So like the blue passed the 30, so the 30 wouldn't have, they wouldn't have any number because, blue wouldn't have any number because he's in the middle of 40 and 30.
So what's interesting is I feel like we're at a place where we're trying to make sense of what these numbers are, right? Like, what are they showing us? Maybe if I give you this information too, that whatever the bottom here is, it represents elapsed game time in seconds. So if this represents time, what do you think those numbers could represent?
Minutes.
Well, it's all minutes or time,
Seconds.
but what could we be describing? Maybe if we give you a little bit more here. Maybe if we explain that this is a game summary and those values are points. What could this then be describing? What is this graph about then? Yes.
I think like when you said points, I thought you were talking like an actual game.
Now,
People.
that's a really interesting moment here. Because we have game time and points and a game summary, you're saying that this could actually represent a game that happened.
Yeah. That like those numbers are like the score, and the ones that are going up are the seconds.
Well, it actually looks like it's the reverse of that, right? It looks like whatever is going up is the points, and what's going across is the time. So, we're seeing that this could possibly be about a game that took place. When we come back, we're going to try to come up with a story about what happened in this game. But for now, we're going to send it back to the studio. Mike, take it away.
All right, thanks for that, Devin, and thanks to all of the students helping out Devin today at Frank West Elementary School. We do have phone tutors available until 5:30 this afternoon, as we most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. If you do need to email us sometime because you're not around to view the program, you can simply email us at dothemath@kern.org. Preferably if you do that on a Monday, Tuesday, or an early Wednesday, so that way when we see them, when we do the live programming on Tuesday, Wednesday, we can get to those in a timely manner and help you out with those problems. All right, young lady, you ready for more work?
Yes.
All right, over to the board. Here comes another one out of
Write
the
it down,
book.
and then you can take over.
All right, so let's start with some parentheses.
Okay.
3 times 6 divided by 2.
So we're talking
Well,
fraction
put the division symbol,
Okay.
not like a fraction bar. There we go.
divided by
2. Close parentheses. And Jalpeen, what variable, what letter would you like to use this time?
Y.
There we go.
y
Plus 10
plus 10.
equals 3 squared y plus 9. That's it.
Okay.
Now, before you even start, I want you to, in your head, do the left side of the equation. No writing anything down. You can say it to Jesus, and I want you to do that in your head, and then you can work on the right side. But I have confidence you can do this part in your head on the left side at least. So explain to Jesus what's going through your mind and
Tell
how
me
you're
what you would do
doing this.
first, and then kind of walk through the arithmetic of that.
Okay, so I would multiply 3 and 6, which would be 18, and then divide it by 2, which would be 9.
Okay.
And then I have the y, so it would become 9y.
Okay.
And I have the plus 10, so 9y plus 10.
Okay.
There you go.
That sounds
Nicely
fair.
done.
You want to go ahead and write that first step right here? Just go ahead and write your final answer of 9y plus 10. Very nice. And then go ahead and copy over the side next to it. Well, you want to go ahead and do the math on that as well? So what can you do on that part? What can you evaluate here?
I would do the exponent of 3 to
Okay.
the second power.
Which is going to give you
9
9. Go ahead and make those changes there. So we have 9y
plus 9.
plus 9. Now just looking at this, I'm saying a 9y plus 10 is equal to 9y plus 9. Remembering though, we have an equality here, right? This is saying they're equal. So I'm just going to call attention to that. But go ahead if you want to tell me what your next step would be.
I would bring the 9y over here.
Okay, so you want to bring this 9y and move it over here?
Yeah.
So if this is a positive 9y, how would I do the inverse of positive 9y?
You would subtract.
9, yeah, so let's go ahead and make a minus 9y. And of course, because these are equality, what we do to one side, we must also transfer over to the other side. So you're going to also subtract your 9y on this side as well. All right, and so if I have a positive 9y minus 9y, what does that give me?
Y.
Well, I have a 9y, that's 9 of these y's, and I'm saying get rid of all 9 of those y's. So if I have 9 minus 9, what do you end up with?
It's just gone.
Yeah, it's 0y, which is like 0, right? Because anything times 0 is 0. So we'll go ahead and put, so what's left on this side then is
10.
10. So let's go ahead and write our 10 on one side. And then we have an equal sign. I have a similar situation, 9y minus 9y here, which is
Gone.
0. Yeah, they've now been removed, so you're left with the 9 on that side. And we have 10 equals to 9. What happens when we have a number that's not supposed to be equal to another? I mean, do you see that they're not balanced or they're not the same size? So what did we do last time when we had a u was equal to, what was it?
You.
0 and 3. 0 is equal to 3. What was our answer in this case?
It was no solution.
No solution. So we again have another no solution. Looks like Mike gave us another one with the no solution.
Hey, you know what? That's what she has in her book, and I just happened to pick a couple of those where it came out to be no solution. So nicely done, Jalpeen.
Yeah.
Some excellent work on both of those problems, and because of that, we will be sending you to our friends over at Chick-fil-A. So congratulations on that. Hey, we do have phone tutors available until 5:30. We'll have Jalpeen do some more work. We'll go out to Frank West again. We'll do it all right after this. Today we're at Vista Math and Science Academy, home of the Dragons, and we're here to and we're back at Vista Math and Science Academy. We've got some 4th and 5th grade students. They've been working with some sticks and making some different things. Some went 2-dimensional, some went 3. Talked about some angles that you guys had, the measurements of the angles and things like that. Now you have a specific task, and you must accomplish it. Are you all up for it?
Yes.
All right. You can pick one of the stacks of cards. Which one do you like? All right, so go ahead and take those apart. All right, and you guys have that set. Take the clue cards apart, start making what they want you to do.
Square. All the sides are either 1 or 2 sticks long, with no broken sticks. Make the figure.
Okay, so
This one's first, second, third, fourth, fifth, and sixth.
okay, so on the first one, the figurehead.
So remember, look at all of the different clues. Look at all of them, because there might be one that can help you get started a little bit easier than just the one on top.
The two triangles share a side. Make a figure. No segment in the figure is shorter than 2 sticks. Correct. Triangle has a perimeter of 7 sticks. Make the figure.
So if there's 8 sticks in the square, why don't you just do that first?
Yeah.
So there's 8 sticks.
Can we stack them?
They're not going to be stacked. None of these are stacked.
Oh, so we have to make it basically the outside has to be 9. The triangle and the square share side. There are 6 sticks in the triangle.
Maybe
Maybe we could like. So let's take this apart. Maybe
Okay,
it could
so-
be like a big triangle, and then
Think
you
about
just have like 2 sticks on each side.
So the kids are working on finding the exact figure that they need to make with the sticks. A little bit more challenging than they thought at the beginning, but we'll see how they do. So you'll read these 3, you grab the other 3. All right, so go ahead.
No segment in the figure is shorter than 2 sticks.
Nothing is shorter than 2 sticks, is it? Next one.
The figure is made up of 2 triangles that are not congruent.
They're not the same, are they?
No.
No. Okay.
There is a quadrilateral in the figure that has a perimeter of 9.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Keep going.
2 triangles share a side.
Doesn't this side share both of them?
Yeah.
Okay.
1 triangle has a perimeter of 7 sticks.
1, 2, 3, 4, 5, 6, 7. That works.
There are 12 sticks in the figure. The sticks are unbroken and they do not overlap.
And we know that we have 12 sticks. Is that everything? There you go. Nicely done. And there you go. We finally have the stick figures at Vista Math and Science Academy. Once again, the Del Vista Dragons, thank you once again for your hospitality. We had a great visit when we went out there to work with those students. Hey, we do have phone tutors here until 5:30. Right now, we're going to go out to Frank West Elementary and visit with Devin.
Coming to the double box.
Hey, thanks a lot, Mike. We're back here with a very talkative and a very thought-inducing group here at Frank West Elementary. We came back, and one young lady who was very observant goes, "Quiet, they're coming back." I said, "No, keep talking because that's the best part of the show." It's great because the conversations that we've been having about this graph that we left from our last segment have been really thoughtful. So if you're just joining us, we revealed a graph that had no numbers, no labels, and asked our kids, what do you think is happening here? And they asked for a little bit more information. They noted what they observed, the fact that there was a red line and a blue line, and ultimately the red line started to get much higher than the blue line, and then ultimately the blue line reached where the red line was, and then at the last point here, the blue line went above the red. And then they realized that this is based on the labels and the numbers revealed about a game. So the challenge laid out was, describe the game that took place. What do you think happened? So I'll throw it out there to our groups. How would you describe what happened during this game? Let's start off over here. What happened during this game? Well, let's begin with the start. Describe the start of this game. What happened at the start?
That that nobody got no points, and then eventually red got some points, blue got some, and then red stopped getting points, and then blue got more points.
So you noticed right around here that the red team stopped scoring points altogether. And it was at that point that the blue team started to cut into their lead little bit by little bit, step by step, until something happened, right? What happened?
I think that, like, you know how the blue is in the middle of 40 and 30?
So right around here, right? This last little step by blue goes up to this point, okay?
And then the red just stopped in the middle of 30 and 20 instead of 40
So
and 30.
what do you think is happening in the game around this part here?
That red got tired and then blue was not.
So blue had a little bit more energy to continue to fight and power through. Red had no momentum, and they just fell flat until this moment. What do you think this moment is where the blue line jumps up?
That he tried to win and he did.
So at some point, blue did something that ended up being the last part of this game and won. So I think that's a really interesting observation. Now, is that very similar to what everybody else kind of discussed happening? Are there any other details that you think may have happened in the game based on the graph? What else can we add? Or what else did you notice happening? share one more thing that you noticed about our game. Right over here, yeah.
I think that was a basketball game
So that's really interesting. What informs you that you believe this is a basketball game?
because there's red and blue, and I think they're different opponents versing each other.
Based on what you understand about basketball and scoring, and let's say points, do you think that this is a fair number of points for a basketball team to be scoring? Maybe like not NBA level. That's a pretty low-scoring NBA game. But let's say maybe a middle school game or a high school game. Do you think that could happen?
Yeah.
Is there another sport that you think might get these number of points?
Football?
What do you think?
I think maybe the soccer points
Ooh.
because if the other team scores a lot of goalies, then they earn a lot of points. But if the other team, they all get tired, they're not gonna get
Now,
a lot of.
something I'll keep in mind, it looks like this game took place in the course of almost 4,000 seconds. Do you think it's realistic that teams could score 30, 40 goals in soccer in one game? Somebody said football. Okay. So why do you say it could be football as well?
I was gonna say football because footballs count by sevens, and that could be faster to count to a rise to.
So you're looking at some of these jumps and seeing that the jumps are they're a little less than 10, and 7's close to that. And then some of these smaller jumps are smaller than 7. So what else could be another jump in football?
Sixes.
6s, or I'm thinking like field goals, like could be 3s, right?
Yeah.
So that was a really interesting observation. I'm going to reveal a little bit more information to you on this graph. Okay? Now we know what those two lines represent. Now we know that those two lines, the blue is the New England Patriots, and the red is the Atlanta Falcons. We have some light bulbs going off now because this is some history that people remember in this room, right? Because this wasn't just a football game, was this?
No.
To be very timely, because of what's coming up this weekend, this was the game summary of Super Bowl 51. This was an actual game where the Atlanta Falcons jumped up to a tremendous lead. 28-3 at one point. Then, like you observed here, they stopped scoring. Bit by bit by bit, New England comes back and ties the game, sending it to the first ever Super Bowl overtime, at which point the Patriots score a touchdown, end the game, and claim the championship in the biggest Super Bowl comeback in history. Now, it looks like we may have some Los Angeles Rams fans here who are not too pleased to see this come back, but another graph will be created this Sunday. So your challenge, if you're up to it, is going to be to try to create your own graph of what happens in the game. They told the story of Super Bowl 51 without even knowing that they were. Wonderful connections to be made. And when we come back from the break, they're going to create their very own problem based just off of one piece of information. For now, we're going to send it back to the studio. Mike, take it away.
All right, thanks for that, Devin, and we'll have to see what kind of problems those students come up with. Right now, we have another problem. We are through with the equations with you, young lady. You ready for something a little different?
Yes.
All right, head on over to the board. We'll take a look at it under the camera here at the original problem, and then you guys can go ahead and work on it. So in Tim's house, a rectangular swimming pool whose length is 30 meters and width 10 meters is surrounded by grass. The pool and the grassy area make a large rectangle whose length is 50 meters and width 20 meters. What area is occupied by the grass? So that's what we're looking for.
So I'm hearing a couple of words in this, and things that bring to my attention are area. Have you worked with area in the past?
Yes.
Okay, so you recognize the shape that we're talking about. If I was just looking at this large green piece that I'm highlighting here, what type of shape is that we're looking at?
A rectangle.
A rectangle. So we have a rectangle, and you know the area of rectangle, the formula for area of rectangle is?
A base times
Base
height.
times height, right. So what we want to do is look at this a little bit more deeper and say, if we know that this entire rectangle has an area, and so does this smaller rectangle, it also has an area, we want to know a little bit more about finding what is the area, if I was to talk about this green rectangle with this pool missing, or what is the area around it, right? So let's talk a little bit about finding the areas, and maybe I'll let you start off by just showing me what the area, or calculating the area of these two spaces, and then let's talk a little bit further about that, okay? Go ahead and grab a pen if you'd like to grab the black pen, and talk to me a little bit about how you would calculate the area of the, well, what would you start off with? Let me ask you that question. How would you start this problem?
I would multiply 50 by 20 and then 30 by 10.
Okay, so what will 50 by 20 give us? Go ahead and do the math if you'd like off to the side. Okay, and because we're talking about m, which are meters, these are 1,000 meters. Now be careful because we're talking about an actual rectangle, but when I multiply an m by an m, we're actually saying multiply meters squared. So area is always in meters squared. So what I'm going to do is just document that step right there. I'm going to say that the area of the let me just say the large rectangle of the large is 1,000 meters squared. So when I was saying 1,000, we're talking about this entire space, right?
Yeah.
So now what we need to do is calculate the second area. If you want to go ahead and do that, go ahead and make your space over here if you'd like, and tell us a little bit about that. All right. Again, we're multiplying base times height, or length times width, to get the area of this square or rectangle. Perfect. I was watching to see if you would catch on to that meter squared. So you did, and you saw that this is, and I'm going to call this the area of the small. Are you okay with that?
Yes.
And we said that the answer is 300 meters squared. Okay, so what they were saying in this problem is that they have this entire area that they want to put a pool in the middle of, right? So this pool goes in the middle. What is the area of just the grassy area, of the grassy piece? Can you talk me through what you would think and how you understand this problem?
I would subtract 1,000 by 300.
Okay, and what would that do when I subtract?
It would give you 700 meters squared.
And in terms of this problem, when I subtract or take away, aren't I actually just saying get rid of this area in the center? So that makes sense to me to use subtraction. So if you want to, you can go ahead and write the area of grass, and you can put our final answer down right here off the side by writing, maybe write area and then put of grass, or area grass. See how I wrote area large, area small? Maybe you write area, or A, and then grass. Just write it down below there, grass, yeah. And then go ahead and put your final answer. Meters squared. So what we've done is basically just found the area. Like when we had this entire area, we just pulled out the center of the grass, which was 300 meters squared, and we ended up with our final answer of 700 meters squared.
There you go. Nicely done. Good work right there. And we'll be back, and we'll have Jalpeen do some more right after this.
All right.
We've really made a push to allow students to graduate from high school with options. And I think this is just another example of the options that kids have today. Some will go right to the world of work. Some will learn about further certifications they can possibly get. And some will just really figure out what career they may want to have tonight.
Nice. It's not a job fair, so they're not here to hire employees. They're more to turn the light on for kids and get them interested in career opportunities that students probably didn't even know existed. And start to answer some of those questions like, what kind of education do you need for that job? What's a day in the life look like? What skills do you need? How much money do you make?
We're particularly excited about the fact that we have middle school students here as well as high school students because it sets them on a career path early.
That was actually pretty easy. I liked it.
And it gives them an opportunity to explore all the different career options.
I wanted to see engineering stuff, and it was really cool to see how you can build stuff and then program things.
Do you like math? Do you enjoy science? Do you like working with people? Do you want to be outside? Do you want to work with your hands? All of those different things can be found in many different careers.
Well-paying jobs, great benefits. In the past, a lot of the vocational trades didn't get a lot of exposure. We expose them, they come in, they see, and they go, hey, wait a minute, I didn't even know that I could go to school at night and work during the day and make a wage, a decent wage. And it gives them an idea. We have all the vocational trades here, so, if this is not what you want, We have the electricians, we have the operators, we have the carpenters, the sheet metal workers.
It helps a lot based on what I know about engineering. It helps a lot to know what they know, and that could help me become what I want.
There are over 100 vendors here from all different sectors within our county. And so students are able to explore those different career opportunities, understand what's required in terms of education, skills, knowledge, background, and then pursue that. They may not need to make a decision today, but their eyes are opened up to all the possibilities in front of them.
I want them to come away getting excited about a career. Start thinking about, hey, I could do that someday for a living, and start to think about putting a plan together for how they can obtain that career goal.
All right, well, we're back once again, and I've got a problem for you. I know you've done some of these in the past, but we're going to do a little twist on it, all right? So let's head on over to the board, Jesus. I don't know why I called you Jose.
It's okay.
Jesus, if you would be so kind as to put 4 4s with a little bit of space between them.
Okay, so I'm going to write the number 4 times.
And we do this with a lot of students because it's fun to see how they think about obtaining the answer. So we'll put an equal sign at the end. And Jalpeen, choose a number between 11 and 20.
15.
All right, so let's put 15 up there as the answer for equal. Now, you know that you can use addition, subtraction, multiply, divide. You can put parentheses around things if you like. You may also use decimal points, a square root symbol, a factorial symbol. Are you familiar with the factorial symbol and what that means? Jesus,
Sure.
Let's go over factorial quickly.
Okay. So this is the symbol for factorial. And factorial just basically means that whatever number is being like with this factorial symbol on the end of it, it means you just add the sum of those numbers together. So it's
Well,
a nice
we're going to
number.
multiply them.
We're going to multiply these?
Right, so it's going to be 4 times 3 times 2 times 1.
I was doing something with it. My
There you go.
apologies. There we go. Let's go ahead and put these, which is a nice tool that we can use because now we can get really large numbers with just only using 1 4. You're familiar with the game, so this is really nice little cheat that we can use, right? Well, it's not a cheat if we're allowed to use it.
Right, just in case you need it. So,
All right,
young lady, go to it and kind of explain to us your thoughts, what you're doing, why you're kind of thinking about what you're doing.
Okay, so at least talk me through this part and what your order of operations is going to be needed, because I see a couple of things that are going to say like, well, which one would we do first? And so depending on how you set this problem up, we're going to probably want to put some parentheses around there. So maybe just tell me what your thoughts are and how you would solve this problem.
So I would multiply 4 times 4, which would make 16.
Okay.
And then I would divide 4 by 4, and that would be 1.
Okay.
16 minus 1 is 15.
Fair enough. It looks like you already have an answer. And because these are both multiplication and division, we would do this first, left to right. We would do this next, and then the subtraction would just happen on its own. We don't actually need to use parentheses on this one.
There you go,
Very well
nicely done. So leave that up there.
Okay.
Now, I want you to find another way to find 15 other than what you just did.
Okay. So I'll start off by framing this problem one more time for you. And while you're doing that, I was giving you a moment to think. Okay, so it looks like you're thinking about factorial using that.
Yeah.
Okay, so you have 4 times 3, which is 12, times 2, and then times 1 is going to give us the same number, right? So would it help if I wrote it down on one of these? Would you like me to put it on here, 4 factorial right here? Okay, so you're starting off with 24, right?
Yes.
All right. Now, we just got to manipulate these numbers to get us back down to 15.
And it can be done. I've just found one way, so you keep working on that.
Okay. Minus 4, 24 minus 4 would give us 20.
So I can add a subtraction here.
Mm-hmm, you can, yeah. So we have 24, we know, minus 4 is 20.
Yes, I think that's it.
Okay, so let's talk about your math real quick. So we know that this is 4 factorial or 24.
Yes.
Take away 4, or do we want to do the division first?
Division.
Okay, so we're going to have 24, and then this is 1. So 24 minus 4 is 20 plus 1?
Yes.
Okay, so we have 20 right here. I'm going to, maybe if we condense this a little so we can kind of see your thinking. You agree that this is 20?
Yes.
So that looks like this. We have 20, and then you said that this is 1.
Yes.
So what you're saying is 20 plus 1 here.
Oh, wait.
Okay, so that's fine. I mean, we'll now take what we have here and we'll play with it a little bit more and come up with a modification for it. And we can erase these two just so we can kind of see where we're at. You're on the right track, though. I think that we need 1 because we have 20 or 24, which are even numbers. So we know we're going to have to end up with an odd somehow.
Right, and she got the first one so quick. That's why I said, all right, let's try another way to get 15 here.
Okay. This is fun.
And we'll have you work on it for a couple of seconds more, and then what we'll do is we'll go visit Frank West, and then we'll come back. So for another couple of seconds, let's see what you think of here.
So I was thinking 20 minus 4.
Mm-hmm.
And
Oh, okay.
Yeah.
So that's where this was 24 minus 4. Okay, gotcha.
Right.
Okay.
And then 20, and then...
All right, so we're going to let you guys keep working
Okay,
on that.
we'll
Right now,
continue
we're going to
this.
go out for our last opportunity to Frank West Elementary and visit with Devin.
Okay.
Double box.
So they're working on
Hey,
that.
thanks
We
a
can
lot,
continue
Mike.
looking at
Back
this.
here at Frank West Elementary, the conversation is on, and we've really dropped it on the kids here as far as what we're going to be doing. So, we've broken out the Chromebooks. We're in creation mode because we're co-crafting today. And right now, we are co-crafting problems based on the newest addition to the Super Mega Skyscraper Club in Shanghai, China. This is the Shanghai Tower. It's not the tallest building in the world. It's the second tallest building in the world. It is 632 meters tall, and that is about 2,052 feet. It also has 128 floors. In addition to that, you start at the bottom, carry up the stairwell all the way to the top, we're looking at about 3,398 steps. Now, if that sounds like a word problem, it might usually, but there's one piece missing. The question. And so what our co-crafters are doing today, they're coming up with the word problems. So we're looking at the conversations they're having, and it's really interesting. They're coming up with stories. They're inventing characters. They're inventing situations where they may need that information. And what we're going to do is we're going to build those questions and actually put them on these slides that you see. So what I'm going to ask you to do right now is start typing those word problems that you have based on this information into, well, it looks like many of you are in our first slide. You want to just put your question into that slide? Let's do that. So let's look in real time and see how everybody is putting their questions. Go ahead and type your word problems onto that slide. Okay? One of the fascinating things about students' created problems is they always end up being so much more rigorous and so much more complex than anything that they may generally see, because kids are curious people. They are curious about how all this information ties together, and they love pushing other people out to figure that out. But as they do so, they're also coming up with ways in which they would solve the problems they're creating. So you can see that they are entering the content into the problem as is, and they're typing it in real time. And what they're going to create is a slide with 5 different problems and 5 different questions that we together can solve. And we'll go ahead and put this up on the Do the Math Twitter page a little bit later this afternoon if you want to follow along and work on some of these questions. So they're going to continue working on this. And, there's a lot of different questions that you at home might be thinking about putting together. And one that stands out to me is I know that there's 632 meters in this tower and that it has 148 floors. Maybe I wonder how many meters are on each floor. Or if I know the rate between meters and feet, maybe I could figure out how many feet tall this building is. If, as we discussed, there are 3,398 steps in this building, maybe I wonder how many steps per meter or how many steps per floor there are. The beauty of this is, as we're coming up with these, we're thinking about strategies that we might be able to use. So if I'm looking at how many steps are on each floor, I'm thinking that might be a division problem. I divide the number of steps by the number of floors. If I'm thinking about if I had 2 of these towers stacked one on top of the other, then I could start to think about if you put them from bottom to top, how many meters tall could it be? And that would just be either multiplying it by 2 or adding 632 by itself. It could be if you know that this is the second tallest building in the world, how tall might the first building be as an estimate if you don't know the height of the Burj Khalifa in Dubai? This is very wide open, and as you can see, now we're getting into very deep scenarios. One group is thinking about how many floors it might be to the top based on solely the number of meters in a foot. So they are reverse engineering a division problem. So it's really interesting to see how these are being developed in real time based on the conversations that are going on. Because I can tell you, they're way more rigorous than I as an educator or a teacher may be. So we're going to continue to work these out. And as you can see, these questions are taking on very different forms. Now, we're not going to worry about solving these today. We've got all the time in the world to solve them. But questions come along on their own. How many meters are on one floor? Number of steps involved. It's a part of the natural process of creating the problems that we want to solve. That'll do it from here at Frank West Elementary School. For now, we're going to send it back to the studio. Mike, take it away.
All right, thanks for that. And once again, thanks to all of the students out at Frank West Elementary School working hard out there this afternoon. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. We would like to say thank you to Jalpeen for coming in. Did you have a good time?
Yes.
And you were able to solve the other 4, so we'll take a look at that right there. Explain to us what you did quickly.
So I put a division sign right there, which means 44 divided by 4, which is 11, and I put a plus 4, so that way you bring the 4, and 11 plus 4 is 15.
There you go.
Very cool.
Nicely done. All right, come on over here. You are now our newest ambassador. That means you have to tell people about Do the Math. You can do that?
Yes.
You promise?
Yes.
All right, because you have a uniform. This is your new uniform. This is what you will wear Monday through Sunday.
Okay.
Only some weeks. Mom's over there laughing about that, but you make sure you watch it every once in a while, all right?
Okay.
All right. Hey, you know what? We're here until 5:30, but until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.